Okay, so let's take a look at the first quiz, and we'll go over some of the answers, and I'll try to explain each of the steps in case you missed a few on your attempt on the quiz. So the first problem wants us to simplify this expression, this rational expression, and we want our answer to not have any negative exponents. So let's take a look at this. So we have the fraction 15 times m to the negative 5, the entire thing divided by 25 m to the third. So you can see in the top you have the number 15, and that's being divided by 25. So you can actually separate this fraction into 15 25ths times m to the negative 5 over m to the third. That way you can reduce the first fraction the way you normally reduce, and then you can reduce the second fraction using your exponent properties. So to reduce the first fraction, we want to find a common factor to the top and bottom, which is 5. So 5 goes into 15 3 times, 5 goes into 25 5 times, so that becomes 3 over 5 times. Now, to use your exponent properties here, you have a division problem, the same base, so we subtract our exponents. We have a negative 5 in our numerator, and we subtract a positive 3 in our denominator. So that gives us 3/5 times m to the negative 8, which becomes 3 over 5, and m to the negative 8 becomes 1 over m to the 8, so the m to the 8th goes in the denominator. So that's how you simplify the first problem. The second problem asks us for a set that consists of all real numbers between negative infinity and 9, including 9. And we want you to write this set in interval notation. So what we're looking for here is, do you know the difference between interval notation versus set builder notation? So in interval notation, you use either parentheses or a bracket, depending on whether you're including a particular point. For example, in this case, we are going to include 9. And that's going to be our larger number, so we put that to the right. Negative infinity cannot be included, so we have a parenthesis. So all the numbers between negative infinity and 9 can be represented by this interval notation. It's the set of all those numbers. So this is what we're looking for in this particular problem. The third problem asks us to evaluate, which means to find the value of 27 raised to the negative 2/3 power. So we have what we call a rational exponent, which means it's a fraction, and we have the base of 27. One of the easiest ways to do this is, since you're asked to find the cubed root, which is indicated right there that says find the cube root, one of the easiest way to do this is if you can write 27 as some number cubed, which in this case you can. You can say 27 is 3 to the third. So notice all I did was replace 27 with 3 to the third. And now you raise it to the negative 2/3 power. So all you need to remember here is, when you have a power raised to a power, you multiply your powers. You keep your base the same, and you multiply your powers, where your two powers are 3 times negative 2 over 3. And the 3's will cancel, so you're left with 3 to the negative 2. So that asks you to do two things. It says to square the 3, and then to move move 3 squared to the denominator. Flip it. Take the reciprocal. Lots of different ways you may have been taught along the way, but this means 1 over 3 squared. 3 to the negative 2 is the reciprocal of 3 squared, which is 1/9. And that's your answer. Okay? Another approach to the same problem, a lot of students don't think of doing it that way, is you start off and you say, okay, I have three actions I have to take here. You have the action that is required by the number that appears in the denominator of your fraction. That tells you to find the cube root. I tell my students that roots go in the cellar. In New England, at farms, roots go in the cellar. So the bottom, the denominator, indicates a root. Your numerator always indicates the same thing. It's the exponent that you're raising your base to. And again, the negative sign has nothing to do with negative numbers. It just tells you you're going to move this from either the numerator to the denominator or denominator to the numerator. It's the idea of flipping or reciprocation. Okay, so if you take the cubed root first, which is what I would recommend to try to make your number smaller, you find the cubed root of 27, and the cubed root of 27 is 3, and now you're left with 3 to the negative 2. Now you could do your exponent if you'd like. The positive exponent. You say, okay, 3 squared is 9. And now you have this final negative 1, which just says, find my reciprocal or move the 9 to the denominator. That's one approach. Another approach would just be 3 to the negative 2, just knowing what it means is 1 over 3 to the positive 2, which is also 1/9. So as you can see with these exponent problems, there's lots of ways of doing them. I'm sure you may even have your own way. So that's a look at 3 different approaches. Okay. Oops. So let's take a look at our next problem. The next problem says, solve the following equation. One of the things you need to do in this course is you're going to be solving lots of different types of equations. So as you look at an equation, it's good if you can put it into a category. So hopefully when you see 4a, 6x minus 7 equals 21, you can identify it as a linear equation. And there's nothing particularly special going on here with this linear equation. You just want to go about solving it as you normally do. You want to isolate your variable term, which is 6x. And to do that, you want to undo the subtracting of 7 by adding 7 to both sides. It's the inverse operations. You now get an equivalent equation, 6x equals 28. Okay, and now from here you have 6x equals 28, and to undo multiplication you divide both sides by 6, and you get x equals 28/6, which when you reduce it is 14/3. So you can leave it just like that. Okay? So 14/3, some of you may choose to call it 4 2/3. Some of you may choose to say that's equal to 4.6 with a little bar over it. Any decimal, improper fraction, mixed number, it doesn't matter to us. They all represent the same thing. Okay. Let's take a look at this equation. For part D, we have x squared plus 2x equals 12. And again, as our first step, we'd like to be able to classify this particular equation. And we see that the highest power that it's raised to is the second power. So we know that this is called a quadratic equation. So we're going to put that right beside it, quadratic equation. And then we have to think about what strategies have we learned to solve quadratic equations. Well, in this particular case, we have two possibilities, or maybe two, we'll find out. One possibility is, can we factor it? Now, as we know, not all quadratic equations can be factored. So we want to see if we can factor it. Can they be factored? And if not, we know that we can use a quadratic formula on any quadratic equation. But before we use either one of these techniques, we know that all of our quadratic equations must be put in the standard form ax squared plus bx plus c equals 0. It's very important that we put our quadratic equation equal to 0, or neither one of these problem-solving approaches will help us. So the very first thing we have to do here is we have to subtract 12 from both sides of the equation. And we get x squared plus 2x minus 12 is equal to 0. So whenever I can, I try to factor a quadratic equation. And I look at my last term here, 12, and I ask myself, are there any factors of 12? And because there's a subtraction sign in front of there, I say that differ by 2. So over on the side of my paper, I say 12 and 1. Those two factors differ by 11, so that doesn't work. And then I go 6 and 2. Well, those two factors differ. The difference between them is 4, so that doesn't work. And then I got 4 and 3, and those differ by 1. So it does not appear that this can be factored. So now I'm going to rely on my quadratic formula. So in order to use my quadratic formula, it's really important that I can identify what the values of A is, B, and C. So A is the coefficient of your x squared term, which is 1 in this particular case. Okay, and now B is going to be the coefficient of my x term, or my linear term, which happens to be 2. And then C is the constant term, which in this case is negative 12. So now I use my quadratic formula, and I simply replace each of the letters within the quadratic formula. The opposite of b, plus or minus the square root of b squared minus 4ac, the entire thing being divided by 2a. So now let's go ahead and replace each letter with its corresponding value. So the opposite of b is negative 2, plus or minus the square root of 2 squared minus 4 times 2 times negative 12. The entire thing divided by 2 times a. Now often I tell my students that even though it's not part of the formula, I often ask my students to put the 4ac in brackets. And the reason why I do that is that whenever the value of 4 times a times c is a negative number, these brackets help you to differentiate the negative that's part of the number from the subtraction sign in front. Because sometimes students have a tendency to use just one, the subtraction sign, to take care of both of them. And that's not going to work out very well for you, because when you subtract a negative number, it's the same as adding a positive. So now we're back to just kind of simplifying each of these steps here. We have negative 2 plus or minus the square root of 4 take away. And again, because I'm using these brackets, once I put my negative 48 in these brackets, my negative sign that goes with the 48 and my subtraction sign that's part of the formula will be distinguishable. So let's continue this along. Negative 2 plus or minus the square root of 52, all divided by 2. Now that's two of the exact answers, two of the solutions, but in math we like to reduce whenever we can. So when we have a radical, we want to try to find a perfect square that is a factor of this radical. So off on the side up here on top, I'm going to have the square root of 52. And I know that 4 divides that. 4 goes into 52 once. 13 times. I was doing the division in my head when you heard once. I was going 4 goes into 5 once. Subtract the 4, you get 12. And then this becomes square root of 4 times square root of 13, which is 2 square roots of 13. So I'm going to replace the square root of 52 right here with what I've just simplified it with, 2 square roots of 13. So let's do that. Let's replace the square root of 52 with 2 square roots of 13 all over 2. So now our final task is to reduce this fraction. Notice you have two answers here. You have negative 2 plus 2 square roots of 13 all over 2, and negative 2 minus 2 square roots of 13 all over 2. Well, some students do this differently. Sometimes you can separate this out into the two terms that appear there on the numerator, because 2 is the common denominator for the negative 2 on the top and also for 2 square roots of 13. So that simplifies to negative 1 plus the square root of 13, because the 2 is a common factor all the way around. So that 2 cancels with the 2 on the top. That gives you your negative 1. That 2 cancels with the 2 on the top, and that gives you 1 square root of 3. So there's one of your answers, negative 1 plus the square root of 3. And the neat thing about quadratic equations is once you have one of your answers, you know the other. X equals negative 1 plus and minus the square root of 3. There you go. So that's the answer to equation D. Now, the last equation we have here is also a quadratic equation. And often we can start working on quadratic equations by using the formula, especially now that it's already set equal to 0. So it's already set equal to 0. That's taken care of. But what we often forget is to use the idea of looking for the greatest common factor. If there's a greatest common factor to every term on the left-hand side, it would help us if we were factoring it, and even if we were using the quadratic formula, because we wouldn't have to do so much reduction in the end like we did in the problem above. It would help us to simplify our answer. So one thing I'm going to do here with E is I'm going to divide everything on the left side by 3 and everything on the right side by 3, because whatever I do to one side, I have to do to the other. So this gives me x squared plus 2x minus 3 equals 0. So no, I still have exactly the same equation. This equation is equivalent to my first equation, because I've divided everything on both sides by 3. Now I can easily factor this equation. I'm going to be searching for factors of 3 that differ by 2. And that's x plus 3 and x minus 1. Factor that. I set each of these factors equal to 0. X plus 3 equals 0 when x equals negative 3. And x minus 1 equals 0 when x equals 1. So those are my two answers for this particular equation. So if you used your quadratic formula, you would have arrived at the same answers.